All right, so you know how sometimes you're like settling in for a good sci-fi movie marathon, you've got your popcorn and everything,
Yeah.
and you kind of start thinking about like, hey, what are the actual chances of some crazy cosmic event wiping us out? Well, get
Oh.
ready, because today we're diving deep into one of the most mind-bending, end-of-the-world scenarios out there, strange matter. And we've got a ton of research articles and scientific papers to help us break it all down.
Yeah, this is going to be a fascinating one.
Definitely.
So to get started, it all kind of begins with these objects called neutron stars.
Neutron stars. Oh, yeah, those are like the leftover cores of giant stars that have gone supernova, right?
Exactly, and they are unbelievably dense. I mean, a teaspoonful of a neutron star would weigh billions of tons. It's like trying to cram something even more massive than our sun into a space the size of Manhattan.
Whoa, okay. That's some serious density. But what
Big
does
word.
that have to do with strange matter?
Well, it's the conditions inside a neutron star that are just so extreme.
Hmm,
It could actually like fundamentally change the way matter itself behaves. You know how everything around us is made up of atoms,
right.
and those atoms have protons and neutrons?
So the basic building blocks.
Right. But it goes even deeper than that. Those protons and neutrons are made up of even smaller particles called quarks,
Okay.
and normally those quarks are kind of confined, meaning they're always bound together inside those protons and neutrons.
So, like, they can't exist on their own.
Exactly.
So then what happens to those quarks in, like, the crazy crushing environment of a neutron star?
That is where things get really interesting. That immense pressure could actually break apart the protons and neutrons, and it would basically free the quarks
Oh, wow.
into this sort of quark soup.
Quark suit.
Yeah, it's also sometimes called quark matter. Imagine you have this well-structured Lego creation, right?
Yeah.
And then suddenly it's just a chaotic pile of individual bricks, all
Oh,
those tiny pieces just floating around.
so that's how strange starts to fit into the picture here.
It does, but it gets even stranger.
Oh, boy.
There are different types of quarks, and there's this one type called the strange quark, and it's heavier and also much more stable than the other types.
So when you combine that immense pressure with these strange quarks, what happens then?
You get strange matter, and this is where things start to veer into sci-fi territory.
Okay, I'm intrigued.
Strange matter might be the most stable form of matter in the entire universe.
Stable. So that's a good thing, right?
Well, not necessarily.
Uh-oh.
What's fascinating, and also a little unsettling, is that strange matter is thought to be infectious.
Infectious. What do you mean by that?
So any normal matter that it touches
Yeah.
could be converted into more strange matter.
So like a chain reaction, where one tiny bit of strange matter could transform a whole planet.
That's the idea.
Whoa.
Now, thankfully, strange matter isn't something we encounter every day. It's mainly thought to exist within neutron stars. But there's a possibility that small droplets of strange matter, called strangelets,
Strangelets.
yes, could actually get ejected from neutron star collisions.
Neutron star collisions. Those sound pretty intense.
Oh, they are. Imagine two objects, each with the mass of our sun, crammed into tiny spaces, smashing into each other at unbelievable speeds. These collisions are some of the most energetic events in the entire universe. And during those events, strangelets could be flung out into space and potentially travel for billions of years.
Okay, so let me get this straight. We have these hypothetical strangelets, potentially hurtling through space. That could convert any matter they touch into more strange matter. And so far, we've only been talking about neutron stars. What are the chances of one of these things actually hitting Earth?
That's the big question, and scientists are still trying to figure that out.
Yeah, I can imagine.
But before we get into like the potential doomsday scenarios, let's look a little closer at the research on strange matter itself. Like, what are scientists actually looking for?
Right, because it's not like we could just see a strangelet's coming.
Exactly. Detecting strange matter is incredibly challenging. And there's actually a lot of debate about whether it even exists outside of neutron stars.
Okay, so how do they even begin to look for it? It's like searching for a microscopic needle in a cosmic haystack, right?
It really is a challenge. One way is to look for indirect evidence, like unusual signals coming from neutron stars.
Huh?
Or from the aftermath of those collisions.
Okay, so what kind of signals would give them a clue that strange matter might be involved?
Well, one thing they're looking for are variations in a neutron star's spin, or its brightness. If a neutron star were to contain a core of strange matter, it could affect these properties in ways that we wouldn't expect from a normal neutron star.
So it's like trying to figure out what's inside a sealed box by shaking it. And listening to the sounds.
Yeah, that's a great analogy.
I try.
Scientists are also looking for specific types of radiation or particles that might be emitted from neutron stars or their collisions. Particles that would kind of suggest the presence of those strange quarks.
I see. But you mentioned earlier that there's a lot of debate about whether strange matter even exists outside of neutron stars.
Mm.
What are some of the arguments against it?
Well, some scientists argue that if strangelets were as stable and as infectious as we've been discussing, they would have already converted a significant portion of the universe's matter into strange matter.
So the fact that we're still here, surrounded by normal matter, suggests that maybe strangelets aren't as common or as dangerous as some of those theories predict.
That's one line of thinking. Others point to the fact that we haven't observed any definitive signs of strange matter in cosmic rays, those high-energy particles that are constantly bombarding Earth from space.
Right. So the lack of clear-cut evidence has led to some skepticism. But what about those potential benefits you mentioned earlier? Could understanding strange matter actually lead to new technologies?
Absolutely. If we could somehow harness the incredible stability of strange matter, it could totally revolutionize material science. Imagine creating materials that are incredibly strong and lightweight and resistant to extreme temperatures and radiation.
That would be game-changing for so many things, like aerospace engineering, building construction, even medical devices.
Exactly. And then there's the potential for energy production. The energy density of strange matter is thought to be enormous. If we could figure out how to safely extract that energy, it could provide a nearly limitless power source.
Wow. It's amazing how this strange matter, which started as a potential end-of-the-world scenario, has so many potential benefits. But let's go back to the Doomsday scenario for a moment. You mentioned that if a strangelet were to hit Earth, it could trigger that chain reaction and convert everything into strange matter.
That is the theoretical possibility, yes. But keep in mind that the probability of such an event is still being debated. Some scientists believe the chances are incredibly low, while others are more cautious.
Okay, so maybe we don't need to build those underground bunkers just yet. But it's still a fascinating thought experiment. What would it actually look like if a strangelet did hit Earth? Would it be like a giant explosion or something more subtle?
That's a good question, and one that scientists have modeled and debated. Some simulations actually suggest that the conversion process might not be as dramatic as you might imagine.
So no giant fireball consuming the planet.
Probably not. It might be more like a slow, insidious process, starting at a microscopic level and gradually spreading outwards. Imagine a tiny seed, slowly taking root and growing, eventually engulfing its surroundings.
Okay, that's actually kind of creepier than a sudden explosion, like a cosmic silent killer. But what about the sun? You mentioned earlier that a strangelet hitting the sun could have some pretty drastic consequences.
Right. Remember, strange matter is thought to be the most stable form of matter in the universe. So if a strangelet were to collide with the sun, it could potentially start converting the sun's matter into strange matter.
And how would that affect us here on Earth?
Well, the sun's mass wouldn't necessarily change much, but its composition and properties, well, it's possible that the sun would become less luminous, emitting less light and heat. And for Earth, that would mean a dramatic drop in temperature, potentially leading to a global ice age.
So not a fiery end, but a frozen one.
That's one possibility. But again, these are all theoretical scenarios based on our current understanding of strange matter, which is still quite limited.
Right, we're still piecing together the puzzle. But there's one more piece of this puzzle that I want to touch on, the connection between strange matter and dark matter. You hinted at this earlier.
Yeah.
But can you elaborate a bit more on how those two might be related?
Yeah, that's actually one of the most exciting areas of research in this field. You see, we know that dark matter makes up a significant portion of the universe, but we can't see it or interact with it directly.
Right, it's like this invisible glue holding galaxies together.
Exactly. And some scientists have proposed that strangelets, with their extreme density and stability, could be a candidate for dark matter. It's a fascinating idea because it could potentially link this mysterious substance that governs the universe's structure with this equally mysterious form of matter.
So instead of being harbingers of doom, strangelets might actually be a fundamental component of the cosmos. That's quite a twist.
It is, isn't it? It really highlights how much we still don't know about the universe and the strange and wonderful things it might hold. And that's what makes the study of strange matter so captivating. It pushes the boundaries of our understanding of physics, challenges our assumptions about the nature of reality, and opens up a world of possibilities.
It's a reminder that sometimes the most mind-bending concepts in science can lead to the most profound discoveries.
Absolutely. And who knows, maybe someday our deeper understanding of strange matter will lead to technological breakthroughs that we can't even imagine right now.
That's what I love about these deep dives, the way they take us from the edge of cosmic doom to the potential for incredible advancements. But before we get too carried away with futuristic possibilities, I think it's important to acknowledge the ethical considerations that come with such powerful knowledge.
That's a crucial point. With any scientific discovery, especially one with such potentially far-reaching implications, it's essential to consider the ethical ramifications. How do we ensure that this knowledge is used responsibly? What safeguards do we need to put in place to prevent potential harm? These are questions that scientists, policymakers, and society as a whole need to grapple with.
It's a reminder that science doesn't exist in a vacuum. It's interwoven with ethical, social, and political considerations. And as we delve deeper into the mysteries of the universe, we need to do so with a sense of responsibility and awareness of the broader implications of our discoveries. So it's like we've been on this roller coaster with strange matter, from potential cosmic doom to mind-blowing technologies, and now these really important ethical questions. But before we wrap up, I want to come back to you listening.
Yeah, let's bring it back down to Earth for a moment.
When we talk about things like neutron stars and strange matter, it can feel so abstract, so far removed from our everyday lives.
It's true, but I think there's something incredibly profound about exploring these cosmic mysteries, even if they seem distant.
I agree. It's like looking up at the night sky and realizing just how vast and unknown the universe is. It makes our everyday problems seem a little smaller, doesn't it?
It certainly puts things in perspective. And who knows, maybe those seemingly abstract concepts will someday have a very real impact on our lives. After all, just a few decades ago, things like smartphones and the internet would have seemed like science fiction.
That's such a good point. I mean, think about it. The scientists who first discovered electricity probably couldn't have imagined how it would transform our world. Maybe someday our understanding of strange matter will lead to innovations that are just as revolutionary.
It's certainly possible, and that's what makes scientific exploration so exciting. It's about pushing the boundaries of knowledge, challenging our assumptions, and opening ourselves up to the unexpected.
And sometimes it's about confronting our fears and grappling with the unknown.
Absolutely. Facing those fears, those existential questions, can actually be incredibly empowering. It forces us to confront what we value, what we believe in, and how we want to live our lives.
So maybe the real takeaway from this deep dive into strange matter isn't about the potential for cosmic doom or technological marvels. Maybe it's about the importance of curiosity, the power of scientific inquiry, and the courage to face the unknown, both within ourselves and in the vastness of the universe.
Well said. And as we continue to explore the cosmos, I have no doubt that we'll encounter even more mind-boggling mysteries, pushing the boundaries of our understanding even further.
And who knows, maybe someday we'll have the answers to those questions about strange matter, dark matter, and all the other wonders that keep us looking up at the stars in awe.
Until then, keep questioning, keep exploring, and keep that sense of wonder alive.
Beautifully put.
Yeah.
And to you listening, until next time, keep looking up. And maybe keep an eye out for those strangelets. You never know what the universe might throw our way. So it's like we've been on this roller coaster with strange matter.
Yeah.
From potential cosmic doom to like these mind-blowing technologies. And now these really important ethical questions we have to consider. But before we wrap up, I want to bring it back to you listening.
Yeah, let's bring it back down to Earth for a moment.
When we talk about things like neutron stars and strange matter and all this stuff, it can feel so abstract.
Right.
So far removed from our everyday lives.
It's true. But I think there's something really profound about exploring these cosmic mysteries, even if they seem distant at first.
Yeah, I totally agree. It's like when you look up at the night sky and you realize just how vast and unknown the universe really is. It kind of makes our everyday problems seem a little smaller.
It does.
Right?
It definitely puts things in perspective. And who knows, maybe someday those seemingly abstract concepts will have a very real impact on our lives.
Yeah.
I mean, think about it. Just a few decades ago, things like smartphones and the internet would have seemed like science fiction to people.
That's true. That's such a good point. I mean, the scientists who first discovered electricity, they probably couldn't have imagined how it would transform our world. Those maybe someday. Our understanding of strange matter will lead to innovations that are just as revolutionary.
It's definitely possible.
Yeah.
And that's what makes scientific exploration so exciting,
Okay.
It's about pushing the boundaries of knowledge,
Mm.
challenging our assumptions, and being open to the unexpected.
And sometimes it's about confronting our fears and grappling with the unknown.
Absolutely. Facing those fears, those big existential questions, can actually be incredibly empowering.
Yeah.
It forces us to really confront what we value, what we believe in, and how we want to live our lives.
So maybe the real takeaway from this deep dive into strange matter isn't just about the potential for cosmic doom, or even like the amazing technological marvels. Maybe it's about the importance of curiosity,
Yeah,
the power of scientific inquiry, and the courage to face the unknown, both within ourselves and in the vastness of the universe.
I love that. Beautifully said.
Thanks.
And as we continue to explore the cosmos, I have no doubt that we'll encounter even more mind-boggling mysteries, things that push the boundaries of our understanding even further.
Oh, for sure. And who knows, maybe someday we'll have the answers to those questions about strange matter, dark matter, all the other wonders that keep us looking up at the stars.
Until then, keep questioning, keep exploring, and keep that sense of wonder alive.
I love that. Well said. And to everyone listening, until next time, keep looking up and maybe keep an eye out for those strange whalets. You never know what the universe might throw our way.